We're now moving on to the quotient rule derivative problems. And when we're dealing with the quotient rule, we generally have some rational functions or expressions that have a numerator and a denominator. Alright, so if I want to take the derivative of question number 1 here, what you need to do is, if you follow the quotient rule, is that you need to rewrite the bottom. So the quotient rule states that it's the bottom times the derivative of the top. So what's the derivative of x plus 1? Well, the derivative of x plus 1 is just 1. And then we subtract the numerator, which is x plus 1, and then we times it by the derivative of the denominator. In this case, the derivative of x minus 1 is just 1. And then we finish this off by taking the denominator and we just square it. Now for this problem, in my class, you don't need to simplify your final answer, so this answer is an acceptable answer to finish. Alright, let's move on to the next question. So the next question in the homework is question number 5. And once again, we have to take the derivative using the quotient rule. If you want, you could rewrite this problem as x squared divided by x to the 1/2 minus 2. And let's go and take the derivative from that form. Okay, so if we're taking the derivative, we take the bottom and rewrite that as x to the 1/2 minus 2 times the derivative of the top, and the derivative of the numerator is just going to be 2x. And then the quotient rule says that we need to subtract, and we're going to subtract the numerator times the derivative of the denominator. So the derivative of the denominator there is going to be 1/2 x to the power of negative 1/2, and the derivative of negative 2 is just 0. So that would finish off the derivative for the denominator. And then we finish off by taking the denominator and then we square the entire expression. And if you want to just rewrite this so that your powers here are in radical form here, then this would be root x minus 2 times 2x minus x squared. And then if I want to rewrite this expression right here, I can rewrite that as 1 over 2 root x, and then I'm dividing everything by the denominator, which is x to the power 1/2 is just root x minus 2 all squared. Alright, let's move on to question number 6 now. Alright, so for question number 6, once again I'm going to start off this problem by rewriting the radicals in terms of a power here. So this would be y equals to x to the power 1/2 minus 3 divided by x to the power of 1/2 plus 3. Alright, now let's take the derivative here. So I'll write y prime, and the quotient rule states that we take the denominator, and the denominator in this case is x to the 1/2 plus 3, and then we multiply that by the derivative of the numerator, and the derivative of the numerator right there would be 1/2 x to the power negative 1/2. And then let me just get a little bit more space over here. And then we need to subtract the numerator, which is x to the 1/2 minus 3 times the derivative of the denominator, and the derivative of the denominator here is just 1/2 x to the power negative 1/2. Close the bracket, and then we just take the denominator and then we just square the whole expression there. Okay, so that is the derivative, and let's just clean this up by rewriting the powers back into their radical form. So all these expressions highlighted in yellow, I'm just going to rewrite those in terms of a radical now. So this will be root x plus 3, all in brackets, and this expression here would be 1 over 2 root x, and this 2 right there is that 2 right there, minus, well, this expression right here will be root x minus 3 times 1 over 2 root x, and once again this 2 right here is that 2 right there, and then you can finish off by writing the denominator as root x plus 3 all to the power of 2. Alright, so that's the derivative for question number 6. I'm now moving on to example number 2. And for example number 2, I need to find the equation of the tangent line to this expression at the point 1, 2. Alright, so whenever I see the term equation of the tangent line, I can rewrite that as, or I can write down the equation of the line, which is y minus y1 equals to m times x minus x1. And if I continue reading the problem here, I'm given the x and y coordinates, so I can plug those values into the tangent line right away. So now I have y minus, this will be 2, equals to m times x minus 1. Alright, so I've correctly put the values of x and y into the equation of the tangent line. And now the goal is I need to find the value of m, which is the slope. And I find the slope value by taking the derivative of this expression right here by using the quotient rule. Alright, so I'll use my green marker here. So that'll be y prime equals 2. Now the quotient rule states that you need to take the bottom, which is 2x minus 1, times the derivative of the numerator. So the derivative of 1 plus x is just 1, minus the top, which is 1 plus x, times the derivative of the bottom. Now if I look at the bottom very carefully, the bottom is 2x minus 1, so the derivative of 2x minus 1 is just 2. And then I multiply that whole thing by the denominator all squared. So that's the derivative expression, and now I need to find the derivative value at the point 1, 2. So in order to do that, I need to find the derivative when x equals to 1, because that's the x value that's given to me. Okay, so if I want to evaluate f prime of 1, anytime you see an x value, those x values will be replaced with a value of 1. So in this first bracket, 2 times 1 is 2, minus 1, and then that's just a 1 there, minus, well, 1 plus 1 would be 2, and then that 2 just carries on. And then the bottom would be, well, 2 times 1 is 2, minus 1 all squared. So now we can find the derivative value here. Okay, so let's do this very carefully here. 2 minus 1 is just 1. So this is 1 times 1 minus, well, 2 times 2 is 4, all divided by, well, 2 minus 1 on the denominator is 1, and 1 to the power of 2 is 1. So if I evaluate that would be 1 minus 4 over 1, which equals to minus 3. Alright, so minus 3 is my derivative value, so I take this value right here and I plug it in for my m value, and now I can finish off the problem by writing out the final answer, which is y minus 2 equals to negative 3 bracket on to x minus 1. So there is my equation of the tangent line. Okay, let's move on to the next example here, and I believe the next example is question 3 in this case. And in question number 3, I need to find the equation of the normal line to this curve at the value of x equals to 4. Okay, so even if the question says normal line, you should go ahead and write the general equation of the line here, which is y minus y1 equals to m times x minus x1. Now we're given an x value of 4, but I don't have the y value. So with these tangent line problems, you should try to substitute your x and y values right away. So if you want to find your y value, you should go ahead and evaluate f of 4. So this 4 value goes right there. Alright, so if I plug in 4 for all my x values, I will now have 4 divided by root 4 minus 3. And that equals to 4 divided by, and root 4 is going to be 2, so 2 minus 3. If I continue evaluating here, this would be 4 divided by negative 1, which equals to negative 4. Alright, so negative 4 is my y value there, so this will be y plus 4 equals to m times x, and this would be x minus 4 because this y value, this x value would come all the way over there. Alright, so let me just erase all this now since we found our corresponding x and y values. Now, in order for me to finish the tangent line problem, I need to find the value of m, which I'm highlighting here in blue. And if you want to find that m value, which is the derivative value when x equals to 4, I need to take the derivative of the curve that's given to me in this problem. Alright, so before I take the derivative, let me rewrite that as y equals to x over, now root x is just x to the power 1/2 minus 3. Alright, so let's go ahead and take its derivative now. Now the quotient rule states that you take the denominator, which is x to the 1/2 minus 3, and you times it by the derivative of the numerator, so the derivative of x is just 1. And then the quotient rule states that you need to have a minus sign here, times the numerator, which is x, times the derivative of the denominator, and that's going to be 1/2 x to the negative 1/2. All divided by the denominator squared, so x to the 1/2 minus 3 all squared. Okay, so I would now go ahead and now you have to recall that the question gives you an x value of 4, so now you need to evaluate f prime of 4. Alright, so now we need to plug in x equals to 4 for all my x values, and then we need to find the actual derivative value here. Okay, so let's do this here. So if I plug in 4 for that expression, that's the same thing as root 4 minus 3 times by that 1 minus. Now if I plug in 4 there, that's going to be 4 times. Now this expression right here is going to be 1 over 2 root x, and x in this case would be 4. Close that bracket. So once again, this 2 right here is that 2 right there, all divided by, well, this thing right here on the bottom is root x, so that's going to be root 4 minus 3 all squared. And now you have to go out and evaluate this. So root 4 here is going to be 2, so 2 minus 3 is going to be negative 1 times the 1 minus 4 times, well, this expression right here, that's the same thing as 1 over 2 times 2, which is 1 over 4. And you'll notice that this 4 and that 4 will cancel off, giving you just the 1 now. And on the denominator here, root 4 is 2, so 2 minus 3 is going to be negative 1 all squared. Now if I keep on evaluating this, let's go ahead and finish this off. Negative 1 times 1 is negative 1 minus, well, this whole expression is just 1, all divided by that expression there, which is going to be 1. And if I keep on going here, almost done here, this will be negative 2 over 1, which equals to negative 2. Now this is the derivative value of the slope, but we want to find the equation of the normal line. So if you want the slope that's perpendicular, which is the normal, which is the slope for the normal line, you need to take the opposite reciprocal of this, and that's going to be 1/2. So opposite means it's going to be plus, and the reciprocal of 2 is just 1/2. So my final answer to finish off the question here, if this is my equation of my line here, I remember the y value was negative 4, I believe. So so this would be plus 4 equals to 1/2 times x minus 4. Okay, so this right here is my slope value right there, and these values of plus 4 and negative 4, we got those at the beginning of the problem here, I believe, if I just keep on going on. Yeah, so plus 4 and minus 4, those are the x and y values for this problem. Alright, so let's move on to the next problem in this section here. So at which points, so when we're talking about points, we need x and a y value. Does this expression have a horizontal tangent line? Now, if we have a horizontal tangent line, that basically means that the slope equals to 0. Because if you have a curve, and if you want a slope of 0, that's the horizontal tangent line. So this horizontal tangent line is basically a horizontal line, and a horizontal line always has a slope of 0. So our strategy for this problem is we're going to take our derivative using the quotient rule, and then we're going to take our derivative and set it equal to 0 and find the corresponding x values, and then we can find the corresponding y values. Alright, so let's go ahead and find the derivative here. Now the quotient rule states that you need to take the bottom, which is x squared plus 1, times the derivative of the top, which is going to be 4, minus the numerator, which is 4x, times the derivative of the denominator, and that's going to be 2x. And then we divide all of that by the denominator all squared. Now, since we're looking for the horizontal tangent line here, the points where we have a horizontal tangent line, we have to take the derivative and we have to set that equal to 0. Okay, so when a fraction equals to 0, you only care about the numerator, right? So anytime a fraction equals to 0, a fraction is mathematically equal to 0 when the numerator equals to 0. So we just need to simplify the numerator by distributing. So 4 times x squared is 4x squared plus 4. And then let's go ahead and distribute this. 4x times 2x is going to be 8x squared. So that's going to be negative 8x squared. And then we just set that equal to 0. Alright, so we have some like terms here and here. So if I combine those, 4x squared minus 8x squared is going to be negative 4x squared plus 4 equals to 0. If I leave this 4 here and bring this term to the other side, I get positive 4x squared. And then I can divide both sides by 4. I get 1 equals to x squared. If I square root both sides and continue on here, x is going to equal to plus or minus 1. Okay, so the question states that I need to find the points, right? So here are my x values. Now I need to go ahead and find my corresponding y values. And for my y values, I need to plug these x values back into the original problem. So I need to evaluate f of 1. F of 1 is going to be 4 times 1 divided by 1 squared plus 1. So all I'm doing here is I'm just plugging in the x values back into the original problem. And I'm just trying to evaluate this. So the numerator here will be 4, the denominator will be 2, so that final answer is going to be 4 divided by 2, which is 2. So if I look at this x value and this value of 2 here, one of the points will be 1, 2. Alright, so this is one of my points there. Alright, so the next point I need to find now is f of negative 1. Because if I go back to the plus or minus 1, there's 2 x values, one for positive 1 and one for negative 1. So now I need to evaluate negative 1. So this will be 4 times negative 1 divided by negative 1 squared plus 1. So now my numerator would be negative 4 and my denominator would be 1 plus 1. And my final answer to this part would be just negative 2. So negative 4 divided by 2 is negative 2. And if I look at that value and that value, that gives me a coordinate of negative 1 comma negative 2. So here are my 2 points where I have a horizontal tangent line to the graph of y equals to 4x over x squared plus 1. I'm now moving on to example number 4. And for example number 4, I'm given a table of values of differentiable functions of f and g. And I need to evaluate each of the following problems. So in this first section, or this for the first part of this question number example 4, I'll do problem number 1 first. And then we'll go ahead and do the rest of the 6 problems. Alright, so I need to find h prime of 1. So in order to find the derivative when x equals to 1, I need to take the derivative of this expression right here using the quotient rule. So h prime of x. Now the quotient rule states that I need to write the denominator, which is g of x in this case, and then I need to multiply it by the derivative of the numerator, and the derivative of x cubed is 3x squared. And then the quotient rule states that I need a minus sign, and then I can take the derivative of the, I can write out the numerator now, which is x cubed, times the derivative of the denominator, and that's going to be g prime of x, all divided by the denominator squared, which is g of x. I'll put blue brackets here, all to the power 2. So that's my derivative. And now I need to plug in the value of 1, and then I can find my derivative value. So here's h prime of 1. So anytime you see an x value, these x values are now going to be replaced with 1 now. So this is going to be equal to g of 1 times, well, if I look at this, if x equals to 1 here, that's the same thing as 3 times 1, and 3 times 1 is 3, minus, if I plug in 1 here, 1 to the power of 3 will be just 1, times g prime of 1, all over, if I plug in 1 here, that's going to be g of 1, and g of 1 is all being squared. Okay? Alright, so let's go a little bit further down. Okay, so here's g of 1. So in order to find g of 1, I need to go to my table now. So going to my table, here's g, and there's 1. So g of 1, if I follow that, g of 1 will be negative 1. So that's going to be negative 1 times 3 minus 1 times. Okay, now I need g prime of 1. So g prime of 1, if I go to my table here, here's g prime. Here's 1, so g prime of 1 is going to be negative 3. So I need a negative 3 here, all divided by the denominator squared. So my denominator is g of 1. Whoops. Probably get my green marker here. So g of 1. So if I go to my table again, if I go to g and 1, g of 1 is just negative 1. So my denominator will be negative 1 all squared. Okay, so now you gotta compute this derivative here in general. So negative 1 times 3 would be negative 3 plus 3 all over 1. And that's going to give you a value of, well, I guess in this case just 0, right? 0 over 1 is just 0. So that's your derivative value, which is going to be 0 for that problem. Okay, let's move on to the next one. So same kind of problem where you're given the table, and you're just given a different function this time, p of x, and I need to find the derivative value when x equals to 4 in this case. Alright, so let's go ahead and find the derivative here. So p prime of x equals to, alright, so based on the quotient rule, I need to take the denominator, and then I need to multiply it with the derivative of the numerator, which is f prime of x, and then the quotient rule states minus, and then I can write the numerator, which is f of x, times the derivative of the denominator, and the derivative of x minus 1 is just 1. And then we're going to divide the whole thing by the denominator squared, which will be x minus 1 all to the power of 2. Okay, so once we've taken the derivative, our goal is to find p prime of 4. So p prime of 4. So what that really means is anytime you have an x value, we're going to replace all these x values with 4. So if I put a 4 here, 4 minus 1 here is going to be 3. So this is going to be 3 times. And if I plug a 4 here, that's going to be f prime of 4 minus, if I put a 4 there, that's going to be f of 4 times 1. I mean, if you want to write that, you can, but you don't have to. And if I plug in a 4 on the denominator, 4 minus 1 is going to be 3. So the bottom is going to be 3 to the power of 2. Alright, so now we need to find the numerical values of f prime of 4 and f of 4. Now for f prime of 4, you want to go to the f primes and the 4s, and where they kind of intersect is this value right here, which is negative 2. So if I go ahead and just follow the table here, it's going to be 3 times the derivative value of negative 2 minus, now where's f of 4? F of 4 is over here, that's f, and here's 4. So f of 4, if I follow the intersection here, that's going to be 1. So that will be 1 times 1 all over, now 3 squared is just 9. And now we just evaluate this. This will be negative 6 minus 1 over 9, which equals to negative 7 over 9 as a final answer. Alright, let's move on to the next problem in this section. Question number 3. So same kind of idea. So let's go ahead and just jump right into the derivative of this expression right here. And I need to find the derivative value when x equals to 1. So f prime of x using the quotient rule one more time. So we take our denominator and we times it by the derivative of the numerator. So that's root x. So remember, root x is x to the power 1/2. And if I take the derivative of x to the power 1/2, that's going to be 1/2 x to the power of negative 1/2 minus the numerator, which is root x, times the derivative of the bottom, which will be f prime of x, all divided by the denominator all squared. So I'm just going to put this in a red bracket and write an exponent of 2 there. Okay, so that's the derivative right there. So let's go ahead and now find the derivative value at f prime of 1. So that's going to be f of 1 times, now this expression right here, if I just do that on the side, that's the same thing as 1 over 2 root x. And if I plug in a 1 there, that's going to be 1, that's going to be 1 over 2 root 1 minus, now this root x over here, that's going to be root 1 times f prime of 1 all over the denominator squared when x equals to 1. So I'll put that all in brackets and square it. Okay, so now we've got to find the values from the table here. So f of 1, and we've got to find f prime of 1, and there's another f of 1. Well, here's f, and there's 1, so f of 1 is going to be 2. And f prime of 1, well, here's f prime, and f prime of 1 is over there, so another value I need to look at is 4. Okay, so f of 1 is going to be, so f of 1 will be, sorry, f of 1, if I follow that, that's going to have a value of 2 there, so this will be 2 times, now this expression right here that I'm circling in blue, that's just 1 over 2, minus, well, root 1 is just 1 times, now f prime of 1, if I follow the table, this is f prime of 1 right there, which is 4, times by 4, all divided by f of 1, which we found already, I believe that was 2, so the bottom will be 2 squared. Alright, let's go ahead and now calculate this. So this expression right here in yellow, that's just going to be 1 because those just cancel off. So 1 minus 4 all over 2 squared, which is 4. Final answer is negative 3 over 4. Alright, let's move on to the next one. Question number 4. Alright, so we're slowly getting there to the end. Okay, so let's go ahead and take the derivative of this expression here. So q prime of x. Alright, so I need to write out my denominator times the derivative of the numerator, which is 2 times g prime of x, minus the numerator, which is 2 times g of x, times the derivative of root x. Now remember, root x is the same thing as x to the power 1/2, and if I apply the power rule there, that's going to be 1/2 x to the negative 1/2, and that's the same thing as 1 over 2 root x. Okay, so I'm going to just erase this and just write 1 over 2 root x, all divided by the bottom squared, which is root x, and that's being raised to the power of 2. Okay, so let's go ahead and find the derivative value. So I need to find the derivative value at q prime of 1, so when x equals to 1. So once again, anytime you see an x value, these x's are going to be replaced with 1. So if I continue the pattern here, or continue the problem, sorry, this will be root 1 times 2g prime of 1 minus 2 times g of 1 times 1 over, in this case it'll just be, sorry, I'll write this as 2 root 1. All divided by, the denominator would be root 1 all squared. Okay, so g prime of 1, so here's g prime, there's 1. So the value that kind of intersects there would be negative 3. And we also need to look at, okay, so that's g prime of 1. And g of 1 Actually, I just kind of erased, let me just erase this part. Okay, so a g of 1 right here, if I follow the table, it's going to be this value right there, which is going to be negative 1 in this case. Okay, so let's go ahead and plug those values in. So root 1 will be 1 times 2 times g of 1, and we determined that g of 1 was going to be negative 3 minus 2 times, sorry, so g prime of 1 is negative 3, but g of 1 is going to be negative 1. And this part right here that I'm highlighting here, that's just 1 over 2. All divided by, well, root 1 all squared is just 1. Okay, so I'm not sure if that came out here. So this expression right there is just a 1 down there. Okay, let's go ahead and continue to evaluate this. So this expression right here in yellow, 1 times 2 times negative 3 is going to be negative 6, plus 1 all over 1, which equals to negative 5. So negative 5 is my final answer there. Okay, let's move on. Now we're moving on to question number 5. So we're given another fraction. So I need to find its derivative. Okay, so let's just continue to move forward here. The bottom is g of x plus 1. So I'll put that in a bracket here. Times the derivative of the numerator. So 2 times f of x. The derivative of that is going to be 2 times f prime of x minus the numerator, which is 2f of x, times the derivative of the denominator, and that derivative is simply going to be g prime of x all over the denominator all squared. And for this problem, I want to find the derivative value when x equals to 4. So if I continue the problem now, this is going to be g prime of 4. So anytime you see an x, all these x's are now going to be replaced with 4. So this will be g of 4 plus 1, and I'll put all of that in a bracket, times 2f prime of 4 minus 2 times f of 4 times g prime of 4 all over g of 4 plus 1. And all of that is being raised to the power of 2. All right, so now we gotta replace all these values with so all these values that have letters. I mean, we gotta find their corresponding values on the table, replace them, and then evaluate our final answer. All right, so g of 4. If I look at g of 4 here, so let me get a blue marker here. So g of 4. What's the value of g of 4? Well, here's g and there's 4. So g of 4 has a value of 1. So this will be 1 plus 1, close the bracket, times 2. Now f prime of 4, where's f prime of 4? So here's f prime and here's 4, so f of 4 would be negative 2. So that's going to be negative 2 right there, so f of 4 is just that value right there. Alright, so then there's a minus sign. 2 times f of 4. F of 4, well, f of 4, if I follow that, that's going to be a value of 1. So f of 4 is 1. And g prime of 4, well, g prime of 4 is in the corner here. So g prime of 4, that leads to this value, which is 2. All over the bottom of g of 4 plus 1. Well, we found g of 4 already. So g of 4 was just 1. And then plus the 1, all to the power 2. Alright, so now we gotta just continue to grind this out and get to the final answer here. So we're almost done here. So 1 plus 1 is 2 times negative 4 minus, well, 2 times 2 is 4 all over 1 plus 1 is 2, so 2 to the power of 2. Alright, so this is going to be negative 8 minus 4 all over 4, which will be negative 12 over 4, which equals to negative 3 as a final answer. Alright, so hopefully you're getting more comfortable with finding the values from the table there. I wasn't able to do a good job of tracking the numbers down on that, but hopefully with all the examples we've been doing so far, you're okay with finding the right values from the table. Okay, final question in this homework video, f divided by g. So there's a prime sign right here, so I'm not sure if you can see that. So if I was to kind of rewrite that out, I want to find the derivative of f over g at when x equals to 3. So it's kind of like you're given like f of 3 divided by like g of 3, and then you want to find its derivative. So this symbol right here means find its derivative, right? Which is very hard to see there. So if I find the derivative of this fraction right here, which represents that, you would, still follow the quotient rule, which is g of 3 times the derivative of the numerator, which is f prime of 3, minus the numerator, which is f of 3 times g prime of 3, all over the bottom, which I'll put in blue, g of 3, all to the power of 2. Alright, so now we've got to find the corresponding values here. So g of 3, well, here's g, and there's 3. So if I follow the values here, the value would be 2. So that's going to be 2. Times f prime of 3. Well, here's f prime, there's 3. So f prime of 3 is negative 4. So this will be negative 4 minus f of 3. Here's f and there's 3. So that's going to have a value of 4. So f of 3 is going to be 4. And g prime of 3, well, here's g prime, and g prime of 3 is going to have a value of negative 5, all over g of 3 all squared. So g of 3 we actually already found already. It's this value right there, which is going to be 2. So that'll be 2 squared. All right, let's go ahead and finish this off. I have negative 8 plus 20 all over 4. And that's going to give me a 12 over 4. And 12 over 4 has a value of 3. Alright, so that concludes that video. Done.